Kongsberg Discovery itself is about 1,000 employees, 3.5 billion Norwegian kroner order intake, and we are the technology backbone of the company. The global reach in this area, we have as Kongsberg a large office in Busan, close to the shipbuilding industry. I myself am based in Singapore, which is the hub for the Asia Pacific markets, and further offices in Japan, in Shanghai, and in Australia. And we provide technologies for secure and sustainable oceans. Working with the Sustainable Development Goals, which have a large part of it to do with maritime, and in particular we are looking at the initiatives. We are in the United Nations Decade of Ocean Science for Sustainable Development, running from 21 to 30. And there is an initiative by the Nippon Foundation, JEPCO, Seabed 2030, which is looking at mapping the world's ocean until 2030 in a relevant resolution, which we are supporting and a part of. In actual fact, there is the annual conference next week in Fiji, which we are supporting and attending. So how do we contribute as a company? By providing sensors. So the journey with our sensors started back in 1947 when a gentleman called Willy Simonsen founded Simonsen Radio, known as Simrad, which was later acquired by Kongsberg. And he used the technology that came out of naval applications during the Second World War, sonar technology, for applications in the commercial world. So the first application was fishery sonars, detecting fish, and then later on using the technology for mapping the oceans, mapping sonars, which we still do in a continuous process of developing and bettering them. But the sensors are just a part of the puzzle, and we believe that integration is the key. As a company, we provide many pieces of the puzzle, but the magic lies in integrating these puzzles into an operation, and the integration means efficiency for safe and efficient maritime operations. So we integrate with the bridge system, with the automation on the vessel, and we provide the propulsion and the connectivity to make the vessel work as one unit. Another important technology development over the last years and the years to come is autonomy, marine robotics. When they came onto the market, maybe 30, 40 years ago, they were able to provide data that you were not able to obtain in any other way. So it was about data and data quality. And nowadays it becomes more of a force multiplier. So you use the robotics in parallel with your traditional methods to have more reach, have more bandwidth, and produce more data to high quality and efficient ways, and faster than you would be without the robotics. If you have many platforms deployed, your marine robots, your traditional vessels, you need interconnectivity. So data transmission and remote operations is another aspect of technology development. And then most importantly, digitalization. Bringing the information to the cloud, to the end users of the technology in the format that they can understand. So you deliver information to any stakeholder in any place, in any kind of format that is needed, and that is running under digitalization. So this is how we see it. We start with the sensors, integrating them into a system, bringing autonomy into play, interconnectivity of the three, and then bringing everything into the cloud to make it available in the format that is needed. To give you some examples, the sensors we are talking about, Kongsberg Discovery provides multi-beam sensors that are used to map the ocean floor. We have a large customer base here in Korea with the major research institutions and the mapping authority. And we provide these on the research vessels that are built in Korea, and they are operated by the institutions here in Korea. This is the data that we provide. This is an example of a latest system which shows a car wreck. So this is the type of information you can obtain from these type of sensors. And different water depth up to the full ocean depth. So we have been involved in a project called the 5 Deep, which went out to map the deepest points in the ocean, and the world oceans. So this is an example of the Mariana Trench, which is the world's deepest point in the Pacific Ocean, called the Challenger Deep, and our systems were used to map these. And there was a human expedition going down to this depth in the Pacific Oceans, and similar in the Indian Ocean and the Atlantic, the Northern Ocean and the Southern Ocean. Ocean science, providing information not only of the seafloor, but we use platforms, instrument carriers, mooring systems, gliders, autonomous uncrewed vehicles. We can estimate the biomass, which has always been important, but is increasingly important, to take the right decision on harvesting and sustaining the biomass and life in the sea. We look for non-biological targets, oceanographic layers, current sediments, seabed classification, gas bubbles, marine hazards, which is all an important topic going forward. And these are the instrumentations that we use. Some examples of showing shoals of fish, and our sensors can be used to identify these. So you see the fish, you can estimate the biomass, and you can detect what species it is. So this is essential database for any kind of ecological research and management in the oceans. In addition, we can map the oceanography, so this is showing different layers in the oceans. And then going on to the second example, which is autonomy. And this is really taking off in recent years, and it will be the topic for the coming years when it comes to ocean research. So we have 30 years of experience in this field. So we have a product line called Hak-Young, and we had the first deployments back in the 1980s. We always collaborated with important stakeholders. So we collaborated with the Norwegian Defense Research Establishment and the Norwegian Navy, as well as the major commercial companies.